Kia ora Year 12 and 13. This is a short video looking at a harder trig question that I'm going to cover on Wednesday this week. So if you want to have a go at it first, that's fine. And it comes from a really nice website that I've found called My Library. And it's from, I believe, a high school in Lebanon. And it has lots and lots of really hard maths problems and a great Facebook page. So sometimes I just grab things off there, and that's one of those questions. Now the first thing that probably looks a bit weird in this is this funny thing here, which you won't have seen before. But it's a great piece of mathematical shorthand that is what I call the product operator. So there are two of these operators that we have in maths. First I'll look at the sigma notation, which is similar and the more common. So this tells us that we need to start with our counter set at n is 1 and substitute it into that expression. So that will be 4 times 1 plus 5. Then we put it up to the next integer, which is 2, and we substitute in n equals 2. And we keep going with that until we get to the counter at the top, which is 4. So 4 times 4 plus 5. So that's what we call sigma notation, right? Greek capital letter S. And this is what we call product notation. Now, I don't think anyone calls this pi notation, but I might be wrong. So if we have this from n equals 1 to 3, and we had 4n plus 5, this is just telling me to substitute in, first of all, n equals 1. 4 times 1 plus 5, right? Now, multiply it by the term when n equals 2, times 4 times 2 plus 5. And then multiply it by 4 times 3 plus 5. Okay, so it's a nice shorthand, but that's all it is. It's not something I've seen at once. So the first thing we want to do here in this problem is to write out the expanded version of this thing here. So I'm going to do that on a new slide. But first, I just want to show you the trig results we're going to be using today and how simple they are. So here we go. Okay, so once we've expanded our expression, which I'm about to do, we're going to do some trig. And there are going to be 4 results. The first 2 are the rules for the cosine of things, and then the cosine of the difference of two things, so cosine of a minus b. Related to those is this one down the bottom here, which is the rule for the sine of 2 theta. Now, if you're doing level 3 at the moment, you're probably just getting up to this part of trig, so don't freak out too much. Students in my class, by the time we get to Wednesday, you will have seen these. I'm not sure about Mr. Kane's and Mr. Moyer's classes. And the last result that we're going to use along the way is this one, which should be very familiar to all of you. So if you've done level 3 calc already, and you're in year 13 this year, you should be able to get a fair way through this problem now, just knowing that you are going to be using those results. So I suggest if that's you, pause the video now and try to get through it using those results on your own. Otherwise, I'm going to walk through it step by step. Alright, so we're asked to show that this thing is equal to 1/8. So step 1 is to expand this out. So the first term when n equals 0 is going to be 1 plus the cosine of pi, right, so pi times 2 times 0, I will do this very slowly, over 8, right, so it's that, times 1 plus, now make n equals 1, cos of pi times 2 plus 1, 2 times 1 plus 1 over 8, right, times 1 plus cos. So I'm going to speed up a little bit now. So I've done n equals 0 here, n equals 1, and now I'm on to n equals 2, right, and 2n plus 1 is 5. So here we're going to have cos of 5 pi on 8. Whoops. And the last term will be 1 plus cos of, well, 2 times 3 is 6, 6 plus 1, so it'll be 7 pi over 8. Right, so we're going to clean that up. So we want to show that proof. It's basically a trig identity. And we will do it by starting with the left-hand side and moving over to the right-hand side. So the left-hand side is that, which is equal to, just cleaning it up, 1 plus cos of pi on 8 times 1 plus cosine 3 pi on 8 times 1 plus cosine 5 pi on 8 times 1 plus cosine of 7 pi on 8. Now, you can sit there and stare at that for a minute, but it's not really very nice. We don't want to have to do some kind of 4-bracket expansion thing. So what we're going to try and do is simplify these here. Now you're probably thinking, well, what does she mean by simplify? Well, I mean we're going to use our sum and difference rules to try and write those more easily. In other words, we don't want to have it being a cosine of pi on 8, then 3 pi on 8, 5 pi on 8, and then 7 pi on 8. So we're going to try and get them boiled down to being the of one angle. And we might suspect we might be able to get them down into building blocks of pi on 8. So that's kind of what I'm thinking, is that it's really gross having these angles all being different. Right? So when you're doing a harder problem like this, you've got to have one eye on where you're headed. And if it's a simplifying problem, often you will want to look for ways to use the sum and difference formulae. So we're going to try that on the next slide. So in here we've got cos of pi on 8 hiding, cos of 3 pi on 8, cos of 5 pi on 8, and lastly cos of 7 pi on 8. So we're going to leave that one alone. We're going to look at a way that we can get this to have a pi on 8 in it. Well, we can do that by saying that cos of 3 pi on 8 is equal to the cosine of 4 pi on 8 minus pi on 8. Right, and then I've got a building block coming in of a pi on 8. We're going to look at cos of 5 pi on 8 and say, well, we can write that as cos of 4 pi on 8 plus pi on 8. And with cos of 7 pi on 8, we can write that as the cosine of pi minus pi on 8. Now I'm going to use the first two of those trig results I had up. The cosine of a plus b is equal to cos a cos b minus sine a sine b, and other way around, cosine of a minus b, which is the first one we learn, is this. But in the case of the first one, there's an even easier way to think about it. So cos of 3 pi on 8 is just cos of pi on 2 minus pi on 8. Right? But we know from early in trig that when you've got your little right-angled triangle, you probably did it in degrees. Sine of x is equal to cosine of 90 degrees minus x. So we're going to use that here, and we can go straight to our answer here, that cosine of pi on 2 minus pi on 8 is equal to the sine of pi on 8. And if you think about your trig graphs of basic cosine and sine function, some of you will see it by that way as well. Right? So for cosine of 5 pi on 8, I'm going to do this by using this thing up here. So that's cos of pi on 2, cos pi on 8, minus sine of pi on 2, sine of pi on 8. Right, now we know, here's my cosine graph, just shoved in there. We know that cosine of pi on 2 is 0, so that first term is 0, minus, and we also should know that sine of pi on 2 is 1, so that's negative sine pi on 8. Right, the next one, the cosine of 7 pi on 8, we can use the same result. So cos pi on 8 plus sine of pi sine pi on 8. Right, looking back at that little graph up there, cosine of pi is negative 1, so this is negative cosine of pi on 8 plus, well, sine of pi is 0. Right, now that's a big mess, so on the next slide I'm going to clean that up and then we'll put it back into the problem and see where to go next. Right, so we've got cosine of pi on 8, we've got cosine of 3 pi on 8, which we worked out was the same as sine of pi on 8, cosine of 5 pi on 8 is equal to negative sine pi on 8, and the cosine of 7 pi on 8 was equal to negative cos pi on 8. Now some of you will have got those pretty quickly from the graphs, and that's fine too. Alright, now we're going to substitute that back into our big expression. Remember, we're trying to show that 1 plus that is equal to 1/8. So now we've got that is equal to 1 plus cos pi on 8 times 1 plus sine pi on 8. Right, remember that's coming from here, so I'm substituting in to the second term, so times 1 minus sine pi on 8, and then 1 minus cos pi on 8. Right, I'm going to do obviously a new slide, and I'm going to write that out and see what we can see. Okay, so I'm going to regroup the order there, and hopefully you will have already seen what I'm doing here. So 1 plus cos pi on 8, and the last one is 1 minus cos pi on 8. One minus sine pi on 8, and 1 plus sine pi on 8. Right, I should start to get a little bit excited at this point, because I've gone from that awful thing at the start to having the product of two differences of two squares. So I've got 1 minus cos squared of pi on 8 times 1 minus sine squared of pi on 8. Right, now if I expand that out, what do we get? Well, we get 1 minus cos squared of pi on 8 minus, I don't know what that's doing there, sorry about that, right, 1 minus cos squared of pi on 8 minus sine squared of pi on 8 plus cos squared pi on 8 sine squared of pi on 8. Right, and then I should get even happier, because I'm going to recognise that this is 1 minus cos squared pi on 8 plus sine squared pi on 8 plus cos squared pi on 8 sine squared pi on 8. So that's 1 minus 1, getting very excited when that happens, plus, let's look at this, cosine of pi on 8 sine pi on 8 squared. Now, what would be really nice here, looking back at those 4 trig results, I had this, the cool one that is the sine of 2 theta is equal to 2 sine theta. Right, so that's a lovely result that falls out of our compound angle formulae. So I can think about doing a trick here where this is now equal to 1/4 of 4 cos pi on 8 sine pi on 8, which is equal to 1/4 of 2 cos pi on 8 sine pi on 8 squared. Right, so the way I knew to do that is because if you've done enough practice with your trig identities and your double angle formulae, which you will all have done by the here, you need to get good at spotting the pattern. So the pattern we're looking for here is a way to take this cosine times a sine and do something with it so that we get it into this form. So we don't have a 2 in here. There's a missing 2 in here. So I'm basically making a 2 in here and dividing it out on the other side. So we're almost done now. So a new slide. So we've shown that huge thing that we started with now equals 1/4 of 2 cos pi on 8 sine pi on 8 squared. Right? Now that's equal to 1/4 of sine of 2 theta, 2 pi on 8 squared, which is 1/4 of sine pi on 4 squared. But we know what that is because we are all over our special triangles. So we have 1/4 times 1 over root 2 squared, which is equal to 1/4 times a half, which is equal to 1/8, as required. Okay, I hope you had fun with that. It's a really nice little proofy kind of question. So if that was a bit bamboozling, especially if you're still in the middle of trig, just take it easy, go slowly through the steps in here, and you might also want to watch my video that proves the first of the compound angle formulae. And we can go through it again on Wednesday. Thanks for watching.